In fact, while people are coming in, let me just do a little poll, okay? Because it's really handy to know what kind of people in the room. So can you do me a quick hands up if you feel that you've heard of Blazor before and have got some kind of concept of what this thing is meant to be about? All right, that's like 90-odd% of people. Very good. And what's also really interesting for me is, hands up if you've actually tried it in some way. You've like run some Blazor-related code. Yeah, that's a lot less, but there's still a good number of you. Okay, excellent. So just for anyone who's not familiar with this, what Blazor is it is a framework for building rich web UI on .NET. And I'm someone who works on that. My name is Steve, and I work at Microsoft. I'm on the ASP.NET Core team, and we've been working on this for about 2 years now. And if you want to know what we're going to be doing in this talk for the next hour, let me set your expectations. For the first 15 minutes, maybe 20 minutes or so, we're going to be looking at some of the core concepts of Blazor, what the programming model itself actually is. And hopefully, for people who have not seen it before, that'll bring you along and get you up to speed very quickly. And then you'll understand where we are today with the Blazor framework. And then after we've done that, we're going to move on and see some slightly more advanced things. I want to spend about 20 minutes to maybe half an hour showing you some features that we're working on at the moment, things that we haven't shipped, but we think they're exciting and they're going to make this even better. So I'm hopefully going to be able to show you a few new things during that phase. And then for the last 10 or 15 minutes of the talk, we'll be casting our minds further forwards into the future even still to get a sense of where this thing could be going in the long term, depending on what people want. OK, so to get started with bringing everyone up to speed, let me give you a very quick history lesson. Okay? We're going to step back in time to the far distant reaches of the past, way back in 2017. Imagine, can you remember what it was like back in those days? If you wanted to build for yourself a rich web application that would run in a browser, then you basically had no choice but to use one of these kinds of things. You would be using a JavaScript-based SPA framework, something like Angular or Vue or React, and your programming would be done in JavaScript. Or maybe you think it wasn't JavaScript because you were doing something else like TypeScript or Flow or something like that. But basically, you're compiling to JavaScript, and that means that at runtime, the semantics of your application is JavaScript semantics and all the interesting behaviors that that entails. And that felt like that was the way it is. That's just the nature of reality itself, and it's never going to change. All our web apps are going to be written in JavaScript. Until one day, this fascinating thing came along, which is WebAssembly. The WebAssembly spec has been around for a few years, but around the start of 2017 is when it became supported by all the browsers. And the idea of WebAssembly is to provide a new bytecode format for the web so that when you're programming for the web, you don't necessarily have to use JavaScript, but you can use whatever kind of language or framework or toolkit you want. As long as it can compile to WebAssembly, then you can run it inside a browser. So that's the idea. And back at those days, early 2017, a lot of people, including myself, got very excited about this and started to think, well, does that mean that somehow we could get .NET to run inside our browsers? And not in the old way, like Silverlight did with a plugin, but this time just purely on native standards. So it's just going to run everywhere, on all desktops, all mobiles. It's just going to work because it's standard. So I started doing a little bit of prototyping of this, and I found, to my surprise and delight, that very quickly, yes, it is possible. We can make .NET run on WebAssembly. And it involves 3 ingredients. So the first ingredient is WebAssembly itself, the bytecode format. And you do need support for that in your browser, but that's cool because all desktop and mobile browsers that are written in the last 2 years do have that support. So that's great. Then what else do we need? Well, we need to take a .NET runtime and compile that to WebAssembly so that it can run inside your browser. And that's not as hard as it sounds. So I got that working. And I thought, OK, this is really cool as long as the only thing that I ever want to do is just log stuff to the console. But that's not the only thing I wanted to do. What I wanted to do was build some rich interactive web apps. And for that, I would need a new UI framework. And that's where Blazor comes onto the scene. So Blazor is a UI framework. It's a way of defining the shape of your application, all the components that are in it, the way that you respond to events and what stuff gets re-rendered, all that kind of stuff. And because that's running inside your browser on WebAssembly, if it wants to update the UI, it can just do so directly because it's already there. It can just reach out and interact with the DOM APIs to update what is displayed inside the browser. So that is the original hosting model for Blazor. and it's what we now call client-side Blazor or Blazor WebAssembly. And that's great, and we're working very hard on that. But while we were building it, we realized that we've got something really flexible here because Blazor is not actually tied to WebAssembly in any way. It can actually run anywhere that .NET can run. And so we realized that as well as letting you run your components inside a browser, we could also let you run them on the server. This is what we call server-side Blazor. And so the idea is that we take .NET, which is obviously able to run on the cloud in some servers, and you can run your Blazor components there in the cloud instead of in a browser. And then when you want to update the UI in someone's browser, we can reach out over a Signal or WebSocket connection and do those updates in real time. So we'll talk a bit more later in this talk about these different hosting model choices and what the pros and cons of them are. But the point I want to make at the start is just that this is a flexible system. So if you buy into the idea of building your UI with Blazor, then you get the choice to run it wherever and whenever, however you want. You can run it inside a browser on WebAssembly. You can run your same components on the server. You can even switch between them dynamically or do whatever you want. It's a flexible system. OK, so that's the sort of big outline of what this kind of thing is. But we haven't really seen it yet. We haven't seen any code. And I know some of you won't have seen that code. So let's bring everyone up to speed with what I mean by the Blazor programming model. How do we build this interactive UI and make it show up in a web browser? And for that, we need a real scenario. So I was thinking, what's a realistic scenario here? Well, how about next week you go back to your company and you start using Blazor. The inevitable result of that is that you'll suddenly be dramatically more successful than ever before. And following on from that, you'll have dramatically more money than ever before. And that leads us to one of the problems with Blazor, which we can all relate to, I'm sure, which is what you're going to do with all that extra money. And to solve that, we're going to need to build some software, OK? Presumably, we need to give the money out as bonuses to all the staff. But who gets the money, and how much do they get? This is a budget allocation problem, and it's not necessarily obvious how you design a UI for that. Here's a real-world example that someone else made. If you're purchasing the Humble Jumbo Bundle 3, cool name, then you get to choose where your money goes to, and you control it with these sliders. So shall we have a go at building a UI like that, and I'll be able to illustrate to you some of the features of the Blazor programming model as we go. OK, let's switch over into my IDE here. I'm doing this in Visual Studio on Windows, but it works just the same cross-platform on VS Code, on Mac or Linux, whatever you like. And I have got this application. And inside my application, what have I got? Well, I've got some C# files. I've also got some Razor files. What are all those? Well, let's just run the code first, and so we can get a sense of what this does. So if I start this up in my browser, then what you'll see is we get something that looks pretty much like a dashboard kind of website. Now this, if you haven't seen it before, is basically what you get when you create a blank new Blazor project using the template. It looks more or less like this. So it's got a few different pages in it. It's got this counter, and it's got this thing that shows you how you can display data. But I'm not really going to focus on those, because I don't think it's super interesting, and you can go and read some other materials online if you want to know about that. What I want us to do is build this bonus splitter component. OK, where is that in the source code so we can start working on it? Well, Blazor is a component-oriented UI framework, which means that your application itself is a component. All the pages in it are components. All the things on those pages are components. So it's this big hierarchy of components all the way down. And the syntax that we use is Razor files. Each one of these Razor files is a component. And in particular, we've got this one called bonus.razor. And if I show you what's in there, you'll see pretty simple right now. Mostly, it's just this static markup, which is the same markup that's being rendered in my page right there. We've also got this page directive at the top, and that is telling the routing system that this component is the thing that we should render if the user goes to this URL of bonus, which is what I am at right here. So that's why that was rendered. OK, so what do we want to do? Well, we want to build this budget allocation UI, and it's going to be interactive. So we will want to bring in a bit of C# code, and we can do that with a code block. Now, I know this is pretty basic stuff for those of you who have already seen it, but we will move fairly quickly, and we will reach some stuff that you probably haven't seen. But for those who don't know, this is where we can put our C# code, and it will run regardless of whether we are inside the browser on WebAssembly or whether we're running on the server. In this application, I'm actually running on the server, but it wouldn't make any difference. Let's go ahead and write a little bit of the logic we're going to need. Firstly, what's the total budget that we've got to distribute? Let's say it's £1 million or dollars, whatever, 1 million units. And we want to decide who it's going to. Well, I've already defined this class called budget item, which has got a name and an amount. And I'm going to define a list of them, a few different categories that we're going to give money to, some to the developers, some to the managers, and some to the sales. Okay? And now I want to render some of this stuff on the UI. So as you know, I can just start writing some normal HTML markup. So I'll have a div with class budget, because I've already got some styles ready for it. And if I want to render something for each of those budget items, I can use a normal C# for each loop, for each var item in budget items, and then I can display some markup for each one of them. And the markup that I actually want to have looks like this. So for each one, I'm going to display its name and its amount, and I'm going to format that as a currency value with 0 decimal places. Okay? Let's see how that looks inside the browser when I reload. You see, we've now got developers, managers, sales. They've all got no money yet, and we want to build an editor for that. So how should we do the editor? Well, I'd like to do it a bit like this with the horizontal sliders. So let's put in some standard HTML range sliders. So we can have input type equals range. And for that, we have to specify what the maximum value is that it goes up to. And I can use the Razor syntax to say that I want it to go up to a maximum value of the total budget. And we can also specify the minimum increment amount. So we'll say it goes up in steps of 1,000, because honestly, who cares about trivial amounts of money less than 1,000 now with this rich, okay? And last thing is, I'm going to use a feature of Blazor called bind, where we can bind the value on that input to the item amount. Okay, let's see if we can now start to edit our budget. Okay, so if I move the sliders, you'll see it does change these budget amounts. That's good. But it's not great so far. There are quite a lot of problems with it right now. One of them is that it's nearly impossible to enter any specific amount of money because you can't see the number change until you let go of the mouse. So what can we do about that? Well, firstly, I'll tell you that when you use bind, that works by listening for the change event inside the browser, and that only fires when I let go of the mouse. So I want to use a different event instead, and I'm going to say that I'll change the bind to listen to the onInput event, which is a standard event inside browsers, and that will fire every time I move the slider. So now, as I move it, you'll see these numbers are going to update in real time. That's great. Okay, still we've got some problems though. One of them is I can't see how much money is left to allocate. I don't know whether I've used it all up or not. So let's display how much money is not yet allocated, and I'll do that by adding a property called remaining, and that will be computed by taking the total budget and subtracting all of the amounts that we have allocated. And then I want to display that on the screen, so I'm going to say we'll display remaining, and we'll format it again as a currency value. Okay, let's see if it's a bit better now. Reload, and so you'll see we've got £1 million remaining, and as we allocate some money, the remaining amount goes down. That's great. But we've still got some problems. One of them is I can allocate more money than I've even got. I can just give everyone loads of money, and then we end up with a negative amount remaining, which is ridiculous. So we need to stop that. Let's make sure that you can't allocate more money than you've actually got. How are we going to do it? Well, let's start with changing the maximum amount that you are allowed to give. So previously, you can give the total budget to each amount, but let's change that. And we'll say that the maximum amount you can give to each thing is the amount that you've already given to it plus the remaining amount, which makes sense, right? You've already got this amount allocated, and then there's this much remaining, so that's how far you're allowed to move the slider. Let's see how things behave now, shall we? So I'll reload, and we'll now see that as I allocate loads of money to the developers, so there's not much money left. Let's say if I want to give some money to managers, then even if I move that all the way up to the top, they only get 193 because that's all the amount that was left. And there's no money left at all right now, so I can't even move the slider for the salespeople. So that's a bit of an improvement, but honestly, it's still really bizarre because these two sliders on the right are in exactly the same place. So it looks like they should have the same amount of money, but they don't. They've got different amounts of money just because of what order I moved them in, which is insane. So what can I do to make this thing make a bit more sense? Well, the basic problem right now is that each of these sliders represents a different horizontal scale amount. So what I need to do to fix this is change the horizontal scale dynamically. And this is a bit of a weird trick that might not be obvious, and you might not even fully make sense of it, even when you see the code, but hopefully you'll like the effect. So I'm going to change the width of each item dynamically so that the width is equal to the proportion of the total budget that could be assigned. So like I said, I know that's not obvious, but let's see what it does. When I come back and reload now, if I give some money to the developers, you can see those lines for everyone else get smaller to represent the fact that there's not as much money left for them. And if I use all the money up, then clearly the salespeople can't have any at all. And I quite like this design because if I decided that I do want to give some money to sales, I have to make a decision about who I'm taking the money away from. So the developers are being a bit greedy right now, so let's take some money away from them. Not too much though, and that leaves a little bit left that we can hand over to the salespeople, okay? So I think that's quite a nice UI, but we could do a little bit of other stuff as well. At the moment, we've still got the problem that you could leave some money unallocated, which is kind of stupid. So how can we stop that? Well, let's add a save button for when you're finished, and we'll say that you're not allowed to save until you've allocated all the money. So down at the bottom here, I'm going to add a button, which I'll spell correctly, and I'll write save as the caption. And I'm going to say that this button will be disabled if the remaining amount is greater than 0. So it's only enabled if there's no money left to be allocated. Let's check that works, shall we? So you can see this button is grayed out right now, but once I allocate all that money, as soon as I do, it pops in and you're now allowed to save, or it's disabled, it's enabled, disabled, enabled. Okay, great. So it works. We've managed to build ourselves a little budget allocation UI. Okay, right, what are the points that I'm trying to make by doing that? My point is to give you a basic sense of the Blazor programming model. So what you've seen is that we can use normal C# code, we can use normal HTML markup, and thanks to Razor, we can mix them together in a very natural and productive kind of way. We get full type safety everywhere, and generally, we have a good time. The other major thing about the programming model in Blazor that I've not shown you yet is how we can package different bits of functionality up in reusable components and nest them together. And I'm not going to do that just now because I think you've seen enough and I want to move on to some different and possibly slightly cooler stuff. Okay, so you've just seen us building an application that was running on the server just then. That was a server-side Blazor application. Let's have a go at moving on to a bigger application now, and this time we're going to run it on WebAssembly. And along the way, I'm going to show you some features that we've not actually shipped or in some cases even implemented yet, just so you can get a bit of a sense of where we're going with this and hopefully get excited about things over the next 6 months. Okay, so what's the scenario for our new application? Well, I thought it would be kind of fun to do something that's not meant to run in a normal web browser, because you know, we do normal browser stuff all the time. What about we do something that's meant to run on a specialized piece of hardware? And the idea I came up with, which is not that exotic, is the following. Are these commonplace in Australia? I have no idea, honestly. They're fairly common in the UK. Okay, so people are shaking their heads. All right, so if you've not seen these before, these are quite widespread in the supermarkets in the UK. I think I've seen them in the United States as well. And the idea is that when you go shopping, you don't necessarily, after you've filled your trolley up, want to go and stand in line and wait for someone to scan all the items. That's kind of dull. So when you walk into the shop, you may find that there's this big bank of devices near to the entrance. And you can walk over and you can pick one of them up, and it turns on, and you take it with you as you're walking around the store. And it's a really cheap little mobile thing that probably runs some old version of Android, but it's pretty, you know, it's adequate for this scenario. And while you're walking around, each time you want to buy something, you scan its barcode, and the device shows you a list of all the stuff that you've got on your trolley and what the total price of it is, so you can keep track of your spending. And when you've eventually finished filling up your trolley, you don't have to go to a normal checkout line. You just go to this special payment area where you scan your order onto the machine, and then it lets you put your card in, pay for it, and you walk out, and you didn't have to line up. So that's saving you a bit of time. Okay? So what we're going to do for the next 20 minutes is build some of the UI that would run on the device itself. And hopefully, as we go, I'll be able to illustrate some of the benefits of using Blazor in general, and in particular, some of the benefits of running it on WebAssembly. Okay. So I'm going to change over to a different solution that I've been working on because I couldn't really do this entirely from scratch during this talk. And in this solution, you'll see that we've got a few projects. But we're only going to focus on 2 of them right now, the client one and the server one. So the server, which I'm just going to start up right now, set as startup project and run that. That's my application's backend server. And that is going to be the thing that knows about all the inventory data for the supermarket. That's got the database of products, and it knows all the prices and things like that, because we couldn't really get that much data onto the little clients. And then the client project, which I'm also going to run in a minute, is a Blazor WebAssembly application. And you'll see in there that we've got all the normal C# and Razor files, things like that. and that's going to run inside the browser. So let's get that to start up in my browser now. Okay, so when that comes up, you'll see we get Blazor Mart. And when I'm running it in development, I'll probably mostly keep it in this landscape kind of shape, but as you saw from my picture before, when you're running it on a real device, it's probably going to be more of this sort of portrait orientation. But let's not worry about the difference. It won't really affect us very much. Let's think about what a user could do with this application. Well, the only thing we really want them to be able to do is to scan their groceries as they go around. So I've got a barcode scanner right here, and I've got various items of groceries. So let's see what happens if I try to scan this tin of beans. I scan it, and you'll see an item pops up in my UI, and a little footer thing appears below that. So how did that work? Let's have a look at some of the code inside this application. Okay, so we've got this component here called app.razor, and that is the root component for my application. You can structure your application whatever you want, but it's probably going to be a fairly deep hierarchy of components that you mostly create yourself with some built-in components. And for this one, I've got a header section at the top, and in there I've got this search box. And that's the thing that deals with responding when you use the barcode scanner. It also just lets you type stuff as well, and as you can see, I've got a sort of autocomplete type thing going on there. You wouldn't really have that on the actual device, but it's just helpful during development to be able to type as well. Okay, so that's my search box at the top. And then below that, I've got my main section. And just like we did in the budget UI, we're using a for each loop, and we're saying for each one of the things that's in your cart, we'll display a cart row display component, which I've also implemented. And below that, we've got an if test that says if you've got something in your cart, then we'll display this footer. So you remember that we didn't have the footer there when we first came, but after I scanned something, the footer dynamically appeared. That's just because this if check here switched from being false to true. Okay, very good. So it seems like we're in a good place here, but obviously this application is not finished because, among other reasons, it doesn't display real product information right now. It just says fake product. Why does it do that? Well, let's see what happens. When you scan something, it calls this handle item chosen method, and that is defined down here. And if I follow the definition to that, we'll be able to see my domain model classes. Now, you may be thinking, what on earth is an EAN? Well, an EAN is a European article number. That's an industry standard thing, and it is literally just the number that's printed at the bottom of a barcode. So that uniquely identifies my products, and I'm passing the EAN into my domain type where it's going to do some stuff. And what does it do? Well, it's a normal C# class, and it's got various bits of logic that I need, like if you've already got one of these in your cart, then we're going to increment the quantity rather than adding a separate row. And if you don't, then we're going to look up the product details from the back end. I'm not really interested in showing you that right now. I am interested in showing you this. This is the method that's going to try and actually talk to the server. Or it should do, but it doesn't do anything like that right now. Currently, it just waits for 1 second and then returns this fake message. So that's why we're getting this fake product thing. So I want to actually get some real data from the back end now. So how can I do that? Well, one really natural and obvious way that you could do this is by making an HTTP request to the back end and asking it to give you a JSON description of the product data. And of course you can do that. That works really naturally. That's the standard way of doing these kinds of things, not just in Blazor, but with most other client technologies. And that's absolutely fine. But there are some drawbacks to fetching JSON over these arbitrary unstructured URLs. One of them is that JSON is not a very efficient format for data transfer over the network. It's very verbose. It's not very efficient. Also, JSON can only represent JavaScript data, so you're limited to the kind of level of precision of stuff that's available for things like numbers in JavaScript. Another issue with it is that it's all very loosely typed. Not just the data itself, but also the URLs that you're making requests to. If you make a request to a certain URL, how do you know that there's even anything listening for that URL? What if they change their schema in some way? It's all very much a sort of best efforts, unstructured kind of thing. So we might wonder, is there a more modern alternative to any of this that might be a little bit more robust? And the answer is, yeah, sure, there's loads of things. People have come up with all kinds of ideas over the years. But one of these ideas that's really started to get a lot of traction in the last year or so is something called gRPC, or Google's Remote Procedure Call Protocol. And that is something that allows us to say, well, let's not transfer data. Sorry, let's not transfer JSON. Let's transfer a more efficient, compact payload, and we'll do so in a very strongly typed way. So we'll get a clear descriptor, a formal machine-readable description about what services are available at a certain endpoint, and so we'll know for sure that we're calling the right thing, and it can all be type checked. So the ASP.NET Core team, you'll be happy to know, has been doing quite a bit of work during the 3.0 release to ensure that we've got excellent support for gRPC on the server. And if you want to learn loads about that, there's a talk by James over there tomorrow where he'll be going into loads of cool details about it. But what I want to do just now is make use of it, okay? So what have I got to do in order to use that from a Blazor client-side application? Well, firstly, I should point out to you that gRPC is not normally usable from inside a browser because it requires HTTP2 natively and various other things. But there is a flavor of gRPC called gRPC Web that is usable by web applications. And that's not in the box with ASP.NET Core 3. However, it's quite easy to add support for using a third-party package, and that's what I've done here. And if you want to see how I've done that, you can get the code for this demo after the talk and have a look at it yourself. The second thing you need to know is that to define these services, we use these special files called proto files. And I've got one on the server right there, inventory.proto. And if I open that up, you'll see this is a description of what data endpoints I can call. And at the moment, I've only got one. It's called autocomplete. And that's the thing that my client calls when I start typing into this text box at the top to get the autocomplete data. But I want to add a new one that returns product information. So I am going to add the definition of a new service called product details. And it takes this particular type of request and this type of response. And I haven't defined those yet. So let me define my request and my response types. And you'll see that the request is the client sends an EAN to the server, the article number, and the server is going to reply just by giving you a single product. And this is the definition of a product up here. Okay? So I want to now fill in an implementation for that. Where should I put the implementation? Well, one of the nice things that the tooling does for us, if you're using this on ASP.NET Core, is that it code generates a base class for you. Here's my inventory service on the server, and it inherits from inventory base, which is generated from that proto file. And it's got virtual methods on it that you can override. So if I type override, you'll see we've now got a product details to override and fill in the actual implementation for our service. And I can do that pretty straightforwardly. My implementation will look like this. I need to make that async. So we'll first wait for a minute, just because otherwise, it's too fast and you can't even see what's going on. And then we will make a lookup inside our database on the server to find that particular product by its ID, and we'll return that back to the client. So that's all I really need to do right now. I'll restart my server with that updated logic. Right, next thing, how can I consume it in my Blazor application? Well, inside my domain model class cart here, I've got something called an inventory client. And if you're wondering where that comes from, I will show you. If I show you inside my project file, I've got this item down at the bottom called protobuf. And I've wired it up to the same proto file that lives inside my server project. And I'm telling the tooling that I want it to generate a client for me. So that will it will automatically create for me a nice, strongly typed way of accessing those services on the server. And that's what this inventory client is. So if I look at the methods on there, you can see I've got autocomplete, and I can call it. And you may be wondering, OK, where's the product details one that I just created? And the answer to that is, well, I haven't recompiled yet, so it hasn't refreshed. So let me just quickly recompile. And when I have recompiled, then we'll try doing that again, like this. And now you'll see that as well as autocomplete, we've also got product details that we can call, and we know what type of data that's going to accept and return. So I'll just drop in my actual logic that I want here, which is pretty straightforward. We'll take that article number, we'll build it into a request, send it to the server, and it's going to give us back a product. Right, let's see if this actually works, shall we? I'll come back to my browser right now, and I will try to scan these beans again. And what do we get? This time we get beans. So it does actually work. What else will I need on my shopping? Well, I think I would like to have some chocolate. And I'm working on a recipe for this novel dessert, so I'm also going to need some wasabi. But my recipe needs a little bit more wasabi just to really bring out the flavor. I make the best desserts. OK, so what have we just achieved? Well, we've got our Blazor application running on WebAssembly inside the client, and we've been able to take advantage of some of the new features that are going in to ASP.NET Core 3, or have gone in, such as the ability to use strongly typed services between a client and a server and a very efficient data interchange format. And you can learn more about gRPC tomorrow. But let's move on. The next thing I want to show you is another thing that we haven't shipped yet, but exists in prototype form, and this is to do with testing. Obviously, and it's an important subject for any developer, and it's something that we've really had in our minds in the very beginning of Blazor. One of our design goals that we've always had is that you should be able to write tests in a really easy, satisfying, and reliable way. But at the moment, we've not really got there. At the moment, if you want to test your Blazor components, you can write a unit test for them, but it doesn't really seem to achieve very much because it's really hard to observe the output of rendering your component. How do you even render it? It's not clear what you would do. The other thing that you can do today is use something like browser automation using a tool like Selenium. And that's something that we do a lot on the team on ASP.NET Core. We use a lot of Selenium stuff to test that the products we're building actually work. So we've got a lot of experience. And what we find is that although it's great that your tests can be really high level and expressive, you can express things in terms of automating clicking inside the browser and observing the state of the DOM corresponding to certain CSS selectors. That's all good. We like that. The negative side of it tends to be that these tests can be a bit slow because they involve launching an actual browser process for each test. And unless you're very careful, they can be unreliable. You really have to know what you're doing to avoid accidentally depending on random details of the timing of the rendering. And so if you're not careful, you end up having tests that are a bit flaky. So what we want is the best of all worlds. We want the ability to write high-level expressive tests in terms of clicks and CSS selectors and such, but we want to run them without running any actual browser. We want them to have the same speed and robustness as native .NET unit tests. So let me give you an example by showing you the prototype that we're working on at the moment. This is something you can try out today, although we haven't shipped it. So I've got this other project here called blazormart.test. And if we look in there, you'll see I've got some unit tests. The first one is this. And what this is going to check is that when the application first comes up, there's nothing in your cart. Makes sense, right? So how it works is it starts by getting an instance of the app component. And if you remember, app is this thing, my root component here. I could write tests about individual subcomponents, but I just wish to write a test about my root component. I can do that. I can do what I like. So what I'm going to do is mount an instance of my app component, and then I'll check that if we search for all the cart items that it's rendered, we'll find that there aren't any. It's an empty set. Okay, that should make sense. Next thing we're going to check is that when you do add something to your cart, initially it shows up as loading. So what we're doing here is, again, we're mounting an app component, and we're doing a bit of funky stuff to mock the data access layer, the gRPC service, to capture any requests that it's going to make, which allows it to make requests. And then the next thing we're going to do is simulate doing what this barcode scanner does. So if you were wondering, what the barcode scanner actually does is it emulates a keyboard. It emulates typing. So when I scan something, what that actually does is it types the EAN into that input for in the top right of my UI, and then it presses the Enter key, which submits the form. So I can simulate doing the same thing from my test by typing into the input and then submitting that form. And then I can hopefully do an assertion that says, if we now look for all the cart items, we'll find that there is one, and the text on it is loading. And then the final test here goes a step further, and that checks what happens when the server responds. So again, we're doing a bit of funky stuff with mocking to say that when the server returns a response, if the response is this product, which has got a name of something cool, then when we look in the UI, we'll see that still there's one item in the cart, and this time the text on it has changed to something cool, and we've got the right price. Okay? Let's run these tests, shall we? They're normal .NET unit tests, so they can run anywhere that you run normal .NET unit tests. You can run them on the command line, you can run them from VS. So I'm going to run these 3 tests in VS right now. I'm just compiling it, and then hopefully they will start running and they will all pass. And you saw that it was basically instant to run all of them because there's no browser. This is just running in process as a unit test. Okay. Right, given that we've got this technology, that gives you some new possibilities for how you do your development. One of those possibilities is you could build your components using a kind of test-driven development process if you want to. And I'm not trying to say that you should or you must use TDD when you're building Blazor components. All I'm trying to say is that you can. You can use whatever test methodology you want, and the technology should be there to support you doing it in whatever way you like. So let's have a go at building a bit of functionality, and we will do it in a test-driven style just to get a sense of whether that's nice or horrible. And the functionality I want to build is this remove item button in the bottom left there. So let's say I've decided that I don't really need the chocolate for my recipe at all. I want to remove it. How can I remove it? Well, I'll tell you how this does work in the actual supermarkets. In the supermarkets, they don't let you just tap on the screen to remove stuff. And I suppose the reason for that is that you might tap the wrong thing and that get really confused. Or maybe you accidentally tap the expensive thing and remove it and then don't pay for it. So what they want is for you to do something a little bit of a more obvious, direct, and physical action to show that you're really removing the thing that you want to, and presumably the CCTV security people can watch that you seem to be doing the right thing. And so what they do is they force you to scan the items out of your cart in the same way that you scanned it in. So what I want to happen is when I click on the Remove Item button, I want the application to switch into a kind of remove mode where it prompts me to scan something to remove it, and then when I scan it does remove it, and we switch back to the normal mode. So that's quite a complicated UI flow there, and I think I would feel better if I had some tests showing that I've implemented that in the right kind of way. So let's build that in a sort of TDD style. I'll start by adding a little outline for my unit test here. It's called CanRemoveItem, and we'll start by simulating being in the same state as before, where we've got one item in the cart. And the next observation I want to make is that initially, there isn't any remove items overlay that covers the screen. So when I do implement this, I'm going to create an overlay that fills everything up, and it's going to have this CSS class. And I'm just checking right now that it's not there by default. So let's run that test and see if it passes. Do we think it should pass? Any opinions? Yeah, should pass, because there isn't a remove overlay, and it does go green. We're all good. Now, following the kind of TDD process, I'm going to keep adding assertions until this starts failing. So my next assertion is going to be that there should be something that's got the CSS class of remove item, and I'm going to click it. And when I do click it, I should see that the overlay that wasn't there before is there now. It's now not null. And in fact, there should be some text inside it that says scan an item to remove. Well, let's run that now, and this time we should expect it to fail because obviously we haven't implemented that yet. So that runs, and indeed it does fail. But does it give us a clear explanation of why it failed? Well, let's find out. It's kind of difficult to read on such a tiny, tiny screen, but if we scroll across, we can see it says, the element does not have an event handler for the event on click. Okay, so it's failing here. It's trying to click remove item, but it says, no, sorry, that thing doesn't even listen for clicks, so this makes no sense, and it dies. All right, so that's correct, because my button remove item doesn't have any click handler. So let's add one, shall we? We'll say on click equals enter remove mode. That's the name of a method, which I haven't implemented yet, so that would be a compile error right now. Let's put in an implementation for that method. Okay, so my method is going to do a very simple thing. All it's going to do is it's going to set a flag to true, is in remove mode. And I better define that flag, so we'll have a bool, not a bol, called in remove mode, and that is going to become true. Okay? Now, we want to display this overlay whenever that bool is true. So we can put in a little bit more markup here that says, if we're in remove mode, we'll have this overlay, and it'll contain this content. You're probably wondering what overlay actually is. Is this some kind of built-in thing? No, it is not. It's something I've defined in my application. It's quite straightforward. Here's the overlay component. All it does is it renders this div with this certain CSS class, which I've styled to fill up the screen, and it just sticks inside there whatever content you've passed to it. And the content I am passing to it in this case is this paragraph tag, which displays scan an item to remove. Right, let's run the test again and see if it goes green this time. Do we think it will? No one's really committing. I hope it does. Let's see what happens. Yes, it does. Good. We've successfully made the remove overlay appear. Well, let's carry on with our little test process now. Now I want to simulate what happens if I scan an item while I'm in the remove mode. So I'm going to say, just like before, I'm going to simulate the scanner typing into that box a certain EAN, and it's the same number that we added before. And once we've done that, since we're in remove mode, the cart should change. It wasn't empty before, but it should become empty now. When we search for all the cart items, that set should now be empty. And the remove overlay should also go away. Okay, let's run our test and see if we've done our job correctly. The answer is, we are not finished yet. We cannot go home for the day. The reason this time is, if we follow the link at the bottom, the assertion that's failing is this one, the assert.empty. Okay, so we scanned the item, but it didn't get removed. Well, that's not surprising since we didn't put in any logic to make it get removed, so let's do that. We'll say if we are in the remove mode, then we'll do something, and if we're not, we'll do what we did before. And there we go. All right, so if we are in the remove mode, we're going to tell the cart that we want it to remove this item. Okay, so hopefully the item should actually get removed now. Let's run our test one more time and see if we're done and we can go and show our product to our customers. Let's find out. Any opinions? Oh, it didn't pass. Why didn't it pass? What's wrong still? Let's find out. Let's scroll down and we'll click the link, and it seems that the assertion that fails now is this one. Yes, because the remove overlay is still on the screen. We forgot to make it go away. So we'll go back over here and we'll say, after you've scanned the item, we'll set is in remove mode to false, and hopefully that will now give us the behavior we need, and our test should hopefully go green. So we build and we run it again, and now all 4 tests are green. We're good, we're happy. And I don't even need to run it in the browser because we're totally confident it works right, but I'm sure you actually do want to see it working, so let's try it. I'll reload, and I'm going to add a couple of things to my cart. I'll get some, oh, I didn't actually focus, right? So we've got some chocolate and we've got some beans, and then we decide we don't really need that chocolate at all. So I'll click the remove, and you'll see we get the overlay. I'll now scan my chocolate again, and the chocolate goes away, and the functionality does work in the way that we thought it did. All right, cool. So that is a prototype unit testing system for Blazor components, which hopefully gives you the same sort of expressiveness that you get with browser automation, combined with the sort of speed and robustness of regular .NET unit tests. Now, that's not something we've shipped. It's a prototype. Hopefully, we'll build something like that. I'm not promising it's going to be exactly that, but we'll make this something like this into an actual product over the next 6 months or so. OK, let's move on. Third and final thing that I'm going to show you, something that we've not got baked in yet, but is quite important and cool, and that is to do with progressive web applications, PWAs. Like I said, we don't have anything for this in the box right now, but it is something you can write your own code for to add some interesting capabilities to your application. And this allows me to illustrate some of the benefits of running on Blazor in WebAssembly specifically, because that makes it a true client-side application. So you can use all of the features that are available to modern client-side web apps. So what kind of thing would we want to do? Well, one of the things that PWAs are really good at is that they can work even if you're offline. And that's actually very relevant for this sort of scenario, because if customers are picking these devices up and walking around with the shop with them, well, presumably it's trying to use the in-store Wi-Fi to do all this kind of connectivity. But Wi-Fi is not 100% robust. What happens if, at the exact moment that someone picks this up and starts trying to use it, that it doesn't manage to have a Wi-Fi connection at that moment? What kind of customer experience are they going to get if the device is offline when they try to use it? Well, I'll simulate that. I'll pretend that I'm offline in my browser, and I'll press the button to start my application, and the customer experience is an error message that just says you're not connected, which is not a cool experience at all, and our customers will not get a good impression of us. So what do we want to do? We want to add some offline support to our application, and because this is a client-side app, we can do it using a service worker. Service workers are something that's just a standard browser feature, and I'll show you how we can do it. Right. In my www folder here, I've got this file called serviceworker.js. And this is something that can be installed into the browser for my application. And it takes charge of various things, such as all the network traffic between this site and my server. And you might be wondering, first of all, hang on a minute, why are you writing this in JavaScript? I thought the whole point here was that we were going to be writing stuff in .NET. Well, the answer to that is that service workers don't run within your application at all. They run in a completely separate context. I can't write it in .NET because there is no .NET there. Well, theoretically, I could use the service worker JavaScript to boot up an instance of the Mono WebAssembly runtime and then run some .NET code inside it. Yeah, I absolutely could, but I really think that would be crazily overkill because a typical service worker tends to be about 30 or 40 lines of code, so I really don't think we need to do all that. And if you're wondering, well, how would I write something like this? How do I know how to write a service worker file? The answer to that from me is basically, well, you don't. You don't really have to write this yourself because service workers are just boilerplate things. They just do standard stuff. So if you want a service worker, just go on the internet and search for service worker boilerplate or service worker cookbook. I think that's what I did. And you can just find various standard service workers that people have written. And I've got one here that implements a certain version of offline support. So the offline logic this uses is it tries to do all the requests through the network if there is a network connection. But if it does that and it finds that you don't have a network connection, then it will fall back on serving cached data into the browser, and hopefully that means things will work when you're offline. So I'm going to install this service worker into my application, and you do that by adding this little call into your index.html saying, browser, hey, using your service worker API, I would please like you to register this service worker.js. Okay, so I've done that now. And so now back in the browser, if I look on my console when I reload, you see we get this message installing service worker. So that sounds promising. And once that's installed, it takes charge of all the network traffic. And so now I've got it to log all the network requests that it sees are happening. And because I'm online, it's letting all those requests be resolved via network calls. But because this is installed as well, that means I don't even need to be online. So if I go back to simulating being offline again, this time when our user starts to use the application and they don't have Wi-Fi, do they get an error message this time? The answer is no. The application just comes up and it starts to work. So that's a pretty cool improvement. But if you're thinking a couple of steps ahead, you might be thinking, well, Steve, you think you're very clever, don't you, making that work offline? But it's not clever at all. In fact, it's stupid and rubbish, because when the user starts walking around the shop, they'll start trying to scan products, and you still can't reach the server, can you? So that's not going to do anything useful at all. Well, OK, let's see what happens, shall we? So this is still my .NET application running inside the browser. It's still going to run all its own logic. I need to focus it. It's still going to run all its own logic. So it's going to try adding stuff to the list, and I can do that as many times as I want. But you're right. We don't have a network connection, so we can't reach the server. But it's really running our actual .NET code, so we can put in whatever kind of retry logic we want. And I've got a little bit of logic in there. So it's retrying, and when our customer walks into a bit of the shop that's got Wi-Fi connection, then let's see what happens. Due to all the retrying logic, all the stuff eventually finishes, and it populates all the data that it wasn't able to get before. So that's not a miracle. It doesn't allow network traffic to work even with no connection, but it does give us a reasonable level of resilience to temporary network outages, which I think is perhaps the best thing that you could possibly hope for with this kind of application. OK. Now, what other things can we do with a PWA? Well, another one of the fun tricks that PWAs can do is be installed into your operating system. So they can install into your start menu on Windows, your dock on Mac, or if you're on a mobile device, iOS or Android, they can be installed with a little icon on your home screen, and then they don't appear to run in a browser at all. They appear to be their own application. And that's a good thing for us, because when our customers are using these devices, we don't want them to think they're using a web browser, because they'll probably start using it for some completely unrelated purpose. So we want them to just see this as being a regular native app that's the only thing that they can run on that device. It's very easy using PWA APIs to make your application installable. All you need is a manifest file. And I've got one here. It's very simple. It gives the name of the application, an icon, and some colors. And I just need to register that in my index.html. So I'm going to add this link tag right here that points to this manifest file. Let's see what effect that has. Now, before I reload, I want you to watch very carefully these icons on the top right up here. You see I've got two icons. We've got Zoom and we've got favorites. But when I reload, because of my manifest, hopefully a third icon will now become available. What's this extra little plus thing that's appeared? Well, that now says install Blazor Mart. And the user, or your sysadmin or whatever, can now install this application onto the device. And if they do that, it no longer shows up in the browser, but it now pops up in its own window without any other browser UI around it. But it's still the real application, and it runs. And the user can do things like find it on their start menu. So if I start searching, you'll see I've got Blazor Mart here that's installed. Click that, pops up in its own window, and it's still the real thing. It's going to do all the stuff that it was doing before. OK, very good. So hopefully that gives you a sense of some of the nice things that we can do with a Blazor application that's running on WebAssembly. What we've done is we've been able to use gRPC to get strongly typed data access with an efficient network traffic. We've been able to write some unit tests in quite a nice, expressive way. And we've been able to take advantage of running inside the client to use some of these PWA features. OK. Now let's change the subject slightly now, and let's think about some slightly broader topics. I want to think about all the ways that we can run a Blazor application. You may remember from the start of this talk that we had this slide before, which talked about client-side Blazor and server-side Blazor. Well, let's just think about these two models a little bit and why you would choose between each of them. In fact, can you even use these? Are these released and supported yet? Well, when it comes to server-side Blazor, that has been shipped already. That is part of the ASP.NET Core 3 release that's already been out for about a month. So that is fully released, fully supported, ready for your production use today. Client-side Blazor, or Blazor WebAssembly, on the other hand, that is still in preview. We've committed to shipping it, but we haven't done so yet, and we've got a targeted release date of May next year. So you've got about 6 months to wait until that becomes a production-supported thing. It has been in preview for a long time. Many, many people have been using it successfully already. Many people have been putting it into production already, even though we tell them not to. But it's up to you. You can go and have a go with that, and hopefully you'll find that it's nice and successful. But again, I want to emphasize what I see as being the main point here, which is that it's flexible. If you build some application using Blazor, then you can run it as client-side, you can run it as server-side, you can change between them, you can use both at once, whatever, it's up to you. You get that kind of flexibility. But still, you might be thinking, all right, thanks for the flexibility, but what do I even want that for? Why would I use one or the other? Well, some of the benefits of using client-side Blazor are that because it's a true client-side application, it will be able to work offline. It's truly in the browser, it can use all the PWA features, and it's just there, running on the client. It means that you're not having to spend any of your server resources on the CPU and RAM needed to run it. It's just there in the browser. And because it's right there, when it wants to update the UI, it does so with 0 latency. So you can write really, really high-performance, rapidly updating UIs that update instantly inside the browser there. Another cool thing about Blazor running on the client is that when it comes to deploying it, as far as your web server is concerned, it's just static files. You can serve it from an ASP.NET Core application, but you don't actually need any .NET on the server at all. If you wanted to, you could serve it from a Node.js application. You could put it on a CDN. You could serve it from Azure Static Websites or something. And just to really prove that to you, I've deployed my BlazorMart application to GitHub Pages. You probably know GitHub Pages is a thing that GitHub gives you that lets you deploy static sites. And here it is. So here's BlazorMart, and you can see it's running from this github.io URL, but it's still the same application that we had before. It still does all the same things that you expected, okay? So that means we've got this very, very cheap and fast geographically distributed hosting available very easily. Okay, that's good. What about on the other side then? What are the benefits of writing server-side Blazor? Well, one of the major drawbacks of client-side Blazor is that it does involve bringing this .NET runtime down into the browser. And at the moment, the default Blazor application is 2.4 megabytes transferred over the wire. So that's quite big. We're working on making it smaller, but still, it's quite big. And also, it requires using the user's CPU to execute. Server-side Blazor, on the other hand, is a thin client model. So that's putting all the load onto the server instead, which means that it's going to work even on super low-end devices. It's going to load just about instantly, even on slower network connections, and the end user's device doesn't have to do the work to update the UI because the server will do it. Okay? Now, another cool thing about server-side Blazor is because your code is on the server, you can do everything that server-side .NET Core can do, including things like interact with arbitrary bits of hardware on the server. So imagine that you want to do some super advanced GPU-powered machine learning thing. Well, that will work incredibly easily with server-side Blazor. Because you're already running on the server, you can just use whatever kind of cloud-based GPUs you want, and it's all just going to execute there and send the results down to the browser. Wonderful. And you don't even have to disclose your proprietary data models. It all just stays up there in the cloud. So that's another major one of the benefits of server-side Blazor. Obviously, the main drawback to server-side Blazor is because you're running in the cloud, all of the interactions are happening over the network. So if there's a lot of latency between the client and the server, end users will see that latency. So we recommend that for a really good user experience, you need to distribute your servers such that each user is within about 100 milliseconds of round-trip time to the server. Okay. Right, so those are the current ways of running a Blazor application. That's what we've committed to ship so far. But what about further down the line? Are there other ways that we can run Blazor? Well, if you came to Ryan's talk this morning, you will have heard about the idea of Blazor and Electron. I'm not going to demo that for you because that was already demoed today, but that allows you to take an Electron shell to run a Blazor application as a desktop application without any WebAssembly involved. So it's using regular .NET Core on the desktop to render the application and use all of the native OS features without being limited by Browser Sandbox. We haven't committed to ship that, but there is a sample that you can use right now if you want. Okay, so that's 3 things. Why have we got this blank space in the bottom right? Well, so far, all the stuff I've talked to you about so far uses web-based rendering. But wouldn't it be interesting if we could use the Blazor programming model but not render HTML and CSS? Could we, instead of rendering that, render native UI elements? Is that even theoretically possible? Well, we've been doing a little collaboration with the Xamarin team to do an experiment on this, to see if we could build native mobile apps for iOS and Android that don't render web pages, but actually render native controls. And I'm emphasizing this is super experimental. We don't even have a sample to share with you, but I'm going to show you a little bit of that right now so you can get a sense of what that would be like and give us some feedback about how you feel about it. So let's have a look at this other application called Blazor Mobile App. Now, thankfully, our friends on the Xamarin team have done most of this work for us, so I didn't have to do this, but I can still show it to you and feel cool about it. We've got this Blazor mobile app up here, which is a normal Blazor application containing C# and Razor files, things like that. And you can see I've got a counter and a to-do list and so on. We've also got these 2 other projects, iOS and Android. So I can run this on either of those 2 operating systems. So let me show you this actually running. And I want to show you this running on a real iPhone. So hopefully, I'm going to be able to make my phone screen pop up on the projector right now. There we go. Okay. So this is a regular iPhone that I've got, and I've built this Blazor mobile application and deployed it to my phone. And when I start that up, you'll see we've got all the things that you normally have in a traditional kind of software demo, such as we've got this counter, so I can click that and it increments a few times. We've also got a to-do list, because obviously everyone has to have a to-do list when they build a new thing. And then finally, we've got this calculator, and it does actually work. So I can solve some maths problems, great. But the important thing to emphasize here is this is not web-based rendering. This is not some kind of web view. This is rendering native iOS elements. And let's just see another thing here. Let's do some to-do list things. So let's say I want to do some stuff, okay? What happens when I press this add button? Well, we get a to-do. We haven't yet implemented the to-do list, okay. So shall we go and implement our to-do list right now? Well, let's see some of the code we've got in here. First, let's look at this counter thing. If you've been doing any Blazor programming, this will look very familiar to you. It's the same sort of thing where we've got some markup and we've got some C# code. And in our C# code, we've got a current count, and we're displaying a label saying how many times you've clicked it. And we've got a button that says when you click it, we're going to run this method increment count, and that will obviously increment the count. And then Blazor knows how to update the relevant part of the UI. As you can see, this is not HTML. I couldn't use HTML here even if I wanted to, because that would involve having some kind of browser to render it. And there is no browser here. This is just native iOS widgets or elements, whatever you call them. OK, let's see this to-do list thing. Well, what's the logic for to-do list? Well, we've got a list of to-do items, and we are going to render them. But we need to let the user type some stuff in. So I've got this string property new text, and I've got a text area, or an entry as it's called, where we can type in some value for the new text. And then there's a button, and when you click it, it calls add item. And currently, that just displays this silly message. So let's put our real logic in. So we'll say to-do items dot add, and we'll construct a new to-do item, and we'll populate the text on that to be the new text. And then we'll set the new text back to be null so that we clear out that text box. Okay? We need to do a bit more there. So we still need to actually display the items. So just like we've been doing all along, we can use normal Blazor style coding patterns. We'll do a C# for each loop. For each item in to-do items, we are going to render, let's say, let's make that go away. I can't stand extra line breaks. We'll make a to-do list item going in there. And the item that we're going to pass to it is the item from this loop. Okay, so that's pretty much all we need. But one last thing is I want to display the number of items that I've still got left to do today. So I'm going to use some normal C# syntax to count up how many things haven't been done yet. So we'll get the to-do items, and we will count all of the items such that the item is not yet done. Okay, let's check that that builds. And it does, all right. So I've deployed that version of my application as well. And so if we run this, when we go over onto the to-do list now, let's get some stuff, and I'll hit add, and it does show up in the list. Let's get some more stuff. Let's have Blazor, and actually I can't be bothered to type, so let's just do this autocomplete thing. Blazor is the time of that time to come to see you. Yes, that makes sense. All right, so we've been able to get our little to-do list to work, and you can see that I can toggle these things, and the numbers all update correctly because we're doing the normal Blazor programming patterns, and everything stays up to date. Okay, so let's just stop that. Right then, so that is all we're going to have time to do in this talk. I hope that's been of some interest to you and given you some ideas about things you can do in your next application. If you want to learn a bit more, if you want to get started with this stuff, then go to this URL, blazor.net, and that will take you to our documentation, which will give you everything that you need to get started. And if you want any of the code, or if you want the slides from this talk, then you can go to that URL up there, and that'll take you into the GitHub repo that's listed below, and you can get the stuff. So I hope that's good for you. I hope you enjoyed it. I hope that you remember to evaluate on your way out. And most importantly, I hope that you have a superb rest of the conference. Thank you.